Hello, welcome back. This is Jim Craig with Learning LinuxCNC. This is our third video in our series on the touch probe. In particular, this touch probe is from CNC 4PC. We're going to, in this video, demonstrate several of the probing routines that are part of the Versa probe screen setup for LinuxCNC. You can download this off of GitHub. Versa has the source code for it there. You can download it off of GitHub and install it to your machine so that you have the same probe screen that I have set up on my machine. What we're going to do is we're going to do several different probing routines. The first one will be a simple down probe, so that it moves the probe down until it touches the top of the workpiece and moves it back up, checks it again at a slower speed to get the actual final height. And we'll do that several times and see how repeatable that is. We'll then do an outside corner where the probe does this type of a move, and we'll look at that, and then we'll do we'll do an inside circle, and we'll actually adjust some settings so that we get some reliable measurements on distance from one point to the next. We'll use that inside circle routine to do so. Then we'll also do some probing on the inside corners of a rectangle to see if we can get reliable measurements there too. So stay tuned. I hope you enjoy the video, and here we go. Here's the probe screen that Versa has made for us to use in LinuxCNC. It has lots of nice probing routines already built into it. We'll go through a couple of them. One thing that I want to mention is that the reason that I crashed my probe was because these settings here defaulted to some millimeter defaults, and my machine set up in inches and I had it all set up in inches, but for some reason it lost my settings and went back to the millimeter defaults, and I went to probe down and it went at 300 inches per minute instead of what I had in here as 10 inches a minute. It went to 300, which should have been millimeters, but in my case it was inches, so it went 300 inches per minute. So another thing to show you is here's a couple signals that I've got set up in my HAL file. One of them is probe present and one of them is probe signal. The probe present is that whenever I plug in my probe, currently it's plugged in. Okay, I just unplugged my probe. You see it went false on probe present. There's a switch in the phone, the stereo jack there, that whenever the plug is plugged in, then my HAL file knows that the probe is actually plugged in and ready to run. Then the probe signal, when the probe is plugged in, it will read false unless I trip the probe, which I'll do here. You see, if I push on the tip of the probe, it trips to true. So that just shows that my probe's working, so that I should be able now to go through the routines and do some probing. So the first one we're going to do is we're just going to do a regular down probe for finding Z height. In here you can have it to where it automatically zeros. Right now I don't have that checked. I'm going to check that box because I want to zero my Z when I go down. So I'll show you the probe setup now, and we'll run through that Z probe height. We'll do it several times to show the repeatability. Okay, so now we're going to do a probe down move. And I've already done one, and it set the 0 to 0. So now I'm going to do another one here. I'm going to turn the auto zero off, and we'll see in the screen here in a minute what the repeatability is. So every time I do it, it should give me a number that's relatively close to 0 as to where the probe stops at. So I'm going to hit the probe down button now. So it's probing down at 10 inches a minute till it finds the surface. Then it backs back up, and now it's going down at 1 inch a minute till it finds the surface again. So now on that probe down, it said that it found it at Z equals 0.0001 inches. So 1/10,000th of an inch difference than the last time. So we'll do it again. And the same thing. Well, actually, I'm sorry. No, this one is negative 1/10,000th. So right now we've got a spread of 3 10,000ths total. We'll do it again. Do it 5 times here and see what we get for 5 times. So that's plus 1/10,000th. And minus 1/10,000th. So we're within plus or minus 1/10,000th of 0 for all 5 probes. So that's pretty good repeatability if you ask me. Now that's a straight up and down probe, and that's the repeatability on the straight up and down probe. Now I'll take a quick video here with my other camera and show you that. Here you see the 5 down probes that I did. The first one went down 1.7489 inches, and it set 0 at that distance. Then it adjusted the G54 offsets, and then on the subsequent probes I turned auto 0 off, and it said that it probed down, and the first time it was plus 1/10,000th, second time minus 1/10,000th, third time plus 1, fourth time minus 1. So within those 2 minutes, 3 minutes, and 5 different probes, we were within one plus or minus 1/10,000ths of 0 with the same exact position. So everything should be pretty close. That's about as good as you're going to get, I think, for a $150 touch probe. So the next one that we're going to do is we're going to do a outside corner, and we're going to do this outside corner here. So it's going to probe from the X direction, then come over the corner, and then probe the Y direction. So when it does this, you want your tip set up so that it is close to that corner that you're going to probe. It doesn't have to be exactly on it, but it should be close to it. Okay, and then it'll move the distances you say here. So it's gonna move a 1/4 inch from where your starting point is. It's gonna move a 1/4 inch each way, and then it's gonna move in a 1/4 inch, or excuse me, it's gonna go out a 1/4 inch to come back in to find that edge. So we'll see that here in just a second. And right now I've got a diameter for the probe tip at 0.050 inches. That's what was working pretty good for my first probe tip. It's not the actual probe tip diameter as measured with a set of calipers, because there's some play before the signal actually trips. So we'll have to see how that works here in a minute. We'll have to play with that when we do an inside circle measurement here on a known diameter circle to see what actually works. Okay, so now you see that my probe tip is approximately over the corner. It's also 0.2 of an inch above the surface we just probed. And the reason I picked 0.2 of an inch is because I'm going to probe down a 1/4 inch from this point to pick up my edges. So I want to be just below this edge when I'm picking it up. So that's why I've got it set to where the probe tip is right now at 0.2 of an inch. And I know where 0 is because I just probed it. So I'm going to go back in the probe screen. I'm going to go to auto 0 again, because I want to auto 0 my X and Y off of this, and then we're going to hit the XY probe button, and we'll see what it does here. So it moves over 1/4. Whoa, went down too far. Oh, I've got my down probe set at a 1/2 inch. I need to change that. That's not accurate at all. So then after it does its probe routine here. It'll go back up to the same height you started at and then put the tip right above 0, 0 as to what it probed. I'm going to change my probe down height to 0.25, and we're going to try this again. And I'm going to leave auto 0 on again, and we're going to do it again. That's better. The good thing is that as long as the machine's not moving so fast that it can't stop, that when the machine detects the probe tripping, it will stop movement if it's not expecting it to be tripped in a probe motion. So I can demonstrate that in a minute. So there, since we weren't quite right on our original height, we had some difference in X and Y this time. But we auto zeroed it now, so we're at 0 right above the corner there. So we're going to do our probe again and check our repeatability on the X and Y. So we're going to do this 4 more times. And I think I could speed up my final probe. I played with it a little bit before. I had it, I think, at 3 inches a minute, and I brought it down to 1 inch a minute. But I think I could go back up to 3 inches a minute and it not have any adverse effects on the accuracy. So that time we were off in X by 0 10,000ths, and we were off in Y by 5 10,000ths. Okay, so here we are. We're going to do the last outside corner probe, and then we'll look at the results on repeatability here for this one corner. Alright, so there we go. And I'll show you the repeatability results. Repeatability on the outside corner probe. You can see our first one we zeroed on, and it had to make a slight adjustment after I went and fixed my problem that I was having. Had nothing to do with the probing. And then after that, we were off by 1 10,000th on X, 2 10,000ths Y, 0, 1, 1, 0, 1, 3. So in general, we're pretty close. We're within plus or minus 3 10,000ths there on all positions, and plus or minus 1 really on X. Plus or minus actually plus 3 minus 1 on Y. So we're within about 6 10,000ths tolerance all the way around. So that's pretty good results. Again, that's not perfect, but it's pretty good. So the next thing we're going to do is we're going to do some probing of an inside of a circle. So we'll use this button here. And what we're going to have to do on that is we'll have to tweak our dimensions here a little bit so that we can probe the circle. The circle that I've got machined is 2 inches exact. So we've got to change the edge length, I believe, is the one we've got to change. So we've got to make that be half the probe diameter, if I recall, or the whole diameter. So we'll actually make it a little bit more than half just to make sure that we get probe contact. So we'll go 1.25, and I'll show you the setup here in a second, and we'll go from there. Okay, so here is a whole probing routine. So once again, you're starting with the tip approximately in the center of the hole. In this case, we're exactly in the center of the hole because we've already probed the hole. And I'm starting with the tip 2/10,000ths above the top surface of the plate. So then whenever we do the probe routine, it'll go down a 1/4 inch, so 50 thousandths below the surface. And come over, probe this side, come to this side, probe this side, and come to here, probe here, then go to there and probe there, then come back to the center and back up to 20 thousandths above, or 2/10ths above, excuse me. So here we go. And also I spoke incorrectly previously when I said that the edge length needed to be slightly larger than the whole radius. It actually needs to be slightly less than the whole radius. So I set it to 3/4 of an inch instead of the 1.25" that I initially set it to. If you set it too big, the routine will stop if it inadvertently hits trips the probe before it starts the probing routine. So there you have. That's the inside circle probe routine. One other thing to note, if you've been noticing while I've been probing with the probe, the LED on the probe is not lighting up in the configuration that I have it wired in. I have positive flowing backwards to the LED so that it will never light. But if you have it wired the other way, then the LED will light when the probe trips. So that can show you when you're making contact, and it'll tell you at least that you're getting power to the probe. It won't necessarily tell you that LinuxCNC is going to see the probe trip, but it'll tell you that you're getting power to the probe. And you can tell that by manually tripping the tip. Whereas if I manually trip the tip, the LED does not come on. The LED does work, it just doesn't work the way I have it wired up. And that has to do with the way that the Pico board requires the current to go. So that's the way I've got it wired in. It also has something to do with the way that I've got my jack wired, so that I can have that plug detect and also the signal from the probe trip occurring at the same time. Okay, so this shows some results from probing multiple times, and during the times that I've been probing here, I've been changing the diameter of the probe tip. That 0.072 is what I have now. The reason I've been doing that is, if you look here, you can look at the LX, the LY, and the D. And both of these numbers, LX, LY, actually all three of them, should be 2 inches exactly. The hole that I'm probing, which is this, is 2 inches to 2.000 inches, as I can measure it with my calipers. It's 2 inches exact. So those numbers should all be 2 inches. So you can see this first couple was right. They were right close to the same repeatability. So you can see LX is 1.98 for both. LY is 1.977 for both. And D was 1.978 for both. So you can see that it's pretty repeatable on that. So then that was with a tip diameter of 0.05. Then I changed the tip diameter to the actual measured dimension of the tip, which was 0.089. So then I put that in, and you can see on the third try, then the diameter is bigger than 2 inches by 17 thousandths. So then I went back and split the difference and put it at 70 thousandths diameter. So then that got me to 1.998 diameter. Then I went 0.71. That got me to 1.999 diameter. Then I went 0.072, and that got me to 2.00 diameter. The interesting thing is that it is measuring slightly different in X as it is in Y by about 0.02 difference. So that's something of note. But now that we have our probe tip diameter set by measuring a known inside dimension, like that circle, then we should get relatively dead nuts accurate positioning at a 0 point. The measurements I was taking earlier, since I didn't have that diameter nailed down, they're going to be slightly wrong, which it didn't really matter. They were just, I was doing them for repeatability. And again, you can see repeatably it's very close. I mean, all the numbers are very close from one test to the next, well within 1/1000th of an inch. So we're doing really good with this probe. It's in my opinion, it's well worth the money from what I can tell so far for the $130, I think is what it was, plus shipping, of course. So it's a pretty good bargain for a touch probe, in my opinion. Looks like the results are going to be usable for sure, and we'll go from there. I'll show you this probe routine with the inside circle, and then we'll do some inside corners on a rectangle also. Okay, so now I'm going to do an inside corner probe here on this one corner. I'll actually probe all 4 corners, and we'll look at the results to see what we get. I'm going to 0 this first corner, and then from there we won't 0. So here we go, we're going to inside probe this first corner. Alright, so we've got our 0 set. Now I'm going to just jog over to there. Go back into our probe screen and we'll probe this corner. Now this rectangle is 2 inches in the long direction and 1 inch the short direction. And again, it's the best I can measure it to about the 0.5,000th, and it's accurate in both those dimensions. So that showed that we're exactly 1 inch wide. Now we're going to jog over to the other corner here. Take a quick look, see if we're about where we need to be. That's close enough. And I'm going to probe that corner. I'm going to go back and look. And it's 2.002 inches long is what it measured out to be. And now we're going to go probe the other corner. And that measured to be 1 inch, nearly exact. So we're going to call that pretty good. I'll show you the results on screen. So that concludes our testing of the touch probe. And from the results that I saw on all the tests that we ran, the repeatability of the probe is very good. The results that we were getting on measurements on the ID of the circle and the inside of the rectangle were all very accurate. They could be a little bit more accurate, but they were, you know, pretty accurate for what I was expecting there. I think that we could do a little bit more fine tuning maybe on the adjustments, and that could get us a little bit closer on those measurements. Some of it I believe is due to some backlash in my machine, so I wouldn't swear 100% of that to be the probe's fault. So, but again, the repeatability of the probing, the results were very good. So I think all in all, the ability of this probe is good for most applications. If you're needing something that's within plus or minus 1,000th, I think this is a good probe for you. If you need something that's more accurate than that, then this may not be a suitable probe for you. But I believe that this is a pretty good value for the money. I do believe that it's more accurate than my edge finders that I have, and when I'm using those on the machine. So it's to be seen for sure in long-term use, but for right now, that's my opinion of it. So I think it's a good value. Like I said, it's a relatively inexpensive, so I believe it's a good value. I hope you've enjoyed the videos on the probe. I hope you've learned a little bit more about it and can make an educated decision on whether or not to purchase it. You know, I've got no dog in the fight whether you purchase it or not, but you know, I thought I couldn't find a lot of information out there about it, so I thought I'd make these videos to show you what I found out about it whenever I started testing it. So if you like what you see on our Learning Linux CNC channel, go ahead and subscribe. We'll be putting out a lot more videos about different topics. I'm going to convert my my CNC router from Mach 3 to LinuxCNC. Probably do that in a couple different fashions. The first one I'm going to do is going to be just a plain parallel port conversion, and then I'll probably switch over to a different control interface later, either using Pico systems or Mesa hardware at that point. So anyway, that concludes our probing series, our touch probe series. And if there's more information you want to know about the touch probe, give me some comments, and I'll see what I can find out. I may have to, you know, add another video to the series so that you can have some more information if there's more detailed stuff you want to see. I'd be glad to do so. I'm not going to produce videos on a high frequency basis, but I'll try to get some out, you know, maybe once a month at least, get a new video out. So I hope you like what you're seeing. Like I said, subscribe if you like what you're seeing, and we'll see you the next time.